Okay, we have 4 questions here from 8.1, all one-step algebraic equations. The first question says 4x equals 3/8. And again, if I was to take this slide here and just say, okay, 4x equals a number, what do I do to isolate the variable? Well, what I would have to do is divide both sides by 4. So over here, I'm going to divide this side by 4 and get me x. But over here, I'm not going to write it like this. What I am going to do is just write divided by 4. Or if you wanted to, you could say, since 4 is a whole number, as a fraction, it would be 4 over 1. They're both the same thing. And the reason why we write whole numbers over 1 is because you learned in grade 8 the easiest way to do division of fractions is to change the multiplication by the flip or the reciprocal of the second. So once you do that, you multiply the numerators, you get 3 times 1, which is 3. You multiply the denominators, 8 times 4 to get 32. And your final answer is x is equal to 3 over 32, or 3/32. In the second question, you have x divided by 4 is equal to 1.5. Now the opposite operation to dividing by 4 is multiplying by 4. And just keep in mind that a quarter of x, right, this is a quarter of x. So we could say it's x over 4, which is a quarter of x. We could also say it's a quarter of x, or we could also say it's a quarter of x. Those 3 things all symbolically represent the idea of a quarter of x. But what we're going to do to get the isolation of it is we're going to multiply it by 4 to get x. This is the world's worst x. And over here, I'm going to multiply by 4 as well. Or, again, since it's a whole number, 4 over 1. Since we're dealing with mixed fractions, we want to change mixed to improper. So 1.5 times 4 is the same thing as 3 over 2 times 4. You can cross-reduce now, or you can just multiply the numerators. If you just multiply the numerators and the denominators, you're going to get 12 over 2, which is going to reduce down to lowest terms of 6, and x is equal to 6. If you realize that when you multiply fractions, you can cross-reduce, 4 over 2 will reduce down to 2 over 1. And now that you've reduced it by cross-reduction, multiply the numerators to get you 6, multiply the denominators to get you 1. Your answer is still x equals 6. In the third question, we have a new coefficient that we haven't seen. Here we had just a whole number coefficient of 4, and we divided both sides by 4 to get rid of it. Here we have a fractional coefficient, and we're still going to use the same idea. We're going to divide by 3 1/5 to get x. And over here, we could have modeled it. We could have said, 1, 2, 3, 4, 4x is equal to, and then a fraction of whatever, and divide it into 4 piles. Here, because we have 3 1/5 x, it does not lend itself well to modeling. But we did divide by 3 1/5, so we're going to divide by 3 1/5 over here. That's going to be the same thing as dividing by the improper fraction, which is 16/5. And once we have that, we know we're dividing, so we're going to change it to multiplication by the reciprocal of 16/5. So the reciprocal, really, if you think about this just for a second, if I said, what's the reciprocal of 3 1/5? The reciprocal is 5/16. And we didn't get that until we changed 3 1/5 to an improper fraction and then flipped that. So now we have the multiplication of these two, which is going to be 1 times 5 is 5. 2 times 16 is 32. And my final answer is the value of x is 5/32, which is kind of close to the answer of the first one, coincidentally. And your last question is a 2-step algebraic equation that you might have seen in grade 8, but you might not have. Here we have something that we haven't seen very often. In most of our questions with fractional coefficients, we have x divided by 4. We multiply both sides by 4. But here, our variable is in our denominator. So I want you to consider the following. If I multiply both sides by x, okay, whatever number that x was, we know that this is the outcome of dividing a number by whatever that denominator was. And that is going to leave me with the number 4 on that side. And over here, negative 3 times x is going to become negative 3x. So now I have isolated the variable onto the different side, but it still has a whole number coefficient. And I'm simply going to divide both sides by negative 3. And x will equal negative 1 1/3. Or if you want, negative 1.3 repeating. Right? I can take 4 and divide it by 3 in a calculator. It's going to give me 1.3 repeating.